Hey there folks, so I want to do a second video tonight and go over some more torque converter information. Tonight I'm going to go over some quality differences and basically the point of this video is to show you that you get what you pay for when we're talking performance converters, and there is a minimum amount of stuff that needs to be done to every performance converter so that it's good enough, period, so that it's good enough to be considered a performance converter. So before I can get into any of those specifics, I gotta mention something that I'm surprised more people don't know, is that almost every single performance and race converter that you buy is built out of some used OEM core. And again, a lot of people don't know that. They'll know now because I just told you. But a lot of people assume you buy a new torque converter, like from whatever brand, pick your brand, that it's new. It's all 100% new parts. It absolutely, most likely will not be. It will be built out of some OEM used core. And there's no problem with that. I'm not saying that as a bad thing. I'm just saying that as a matter of factly, that's the way that it is. It's certainly not a bad thing. There's tons of OEM torque converter cores out there, so they might as well use the pieces that can be used. But you can't just take a GM 245 converter and retrofit it to work with a Chevy V8 behind or in front of a Turbo 350 or 400 or whatever and call it a day. It has to be beefed up and further modified in order to be considered a good performance converter. And that's what I want to talk about in this video. So the first thing that has to be done to take this OEM converter, which this converter right here came behind some 4 or 6 cylinder that probably made 100 horsepower at the most. So the first thing that needs to be done is it needs to be modified so that it'll actually bolt into the application. So the overall height of it needs to be set correctly, the bolt pattern, the hub, both hubs, the turbine or the drive cover hub and the impeller hub need to be appropriate for the application. And then it needs to be beefed up on the inside, which we're going to talk about here in just a second. So I brought a bunch of converters out here kind of for a size comparison difference and also to kind of show the different ways that these are modified. So over there on the far left, I have a big diesel converter. Next to it's an 8-inch Opal. And then there's 1, 2, 3 GM 245 converters that are all modified in different ways. And then there's a 258 converter that's a bolt together with the billet aluminum drive cover. So we're going to be picking on these 245 converters because they're so dang common. I have a million of them here, and I have them in a bunch of different configurations, everything from not good to better to best. So the not good one, all they did to convert this thing was they welded a hub on there to fit in the crankshaft. They welded tabs on there so the bolt pattern is correct, and they welded an impeller hub on. That's it. That's all they did. And then inside, well, we'll talk about the inside in a minute. So what are better ways to do it? So a better way to do it would be to weld a ring on the front of it. This ring is going to add rigidity and strength to the entire torque converter. And then also to weld this big flange on the front, on the impeller side, also known as or referred to as an anti-ballooning plate, even though I'd really love to see a ballooned torque converter. People talk about them all the time, but I've been building performance transmissions for 30 years, and I have not seen one yet. I've seen some mugged up converters, but I don't know if I've seen one that actually ballooned and like blew up like a balloon. But anyway, I'm sure it does happen, or they wouldn't call them that, but it's also referred to as an anti-balloon plate. It's a reinforcing plate that reinforces the impeller, and sometimes they'll also weld a reinforcing plate onto the drive cover side to reinforce that as well. So this plate was added and welded onto this converter. And see, this one has a ring fully welded on it. This is a pretty robust converter. This is kind of how, I think every performance converter for high power application was done up until very recently, when the billet one-piece drive cover started getting more popular, which, that was mainly due to CNC machines where they could be mass produced easier. So anyway, that's the best way to do it with the weld together converter, is to have a one piece steel drive cover that gets away from those stamped pieces, and it already has the correct bolt pattern and pilot. And a lot of times you'll have a spin-on pilot or a press-on removable, replaceable, extendable pilot that you can custom tailor to the application for different mid-plate thicknesses and crankshaft setups and stuff. So anyway, the one-piece billet drive cover is the best way to do it. The next step up, or the very best, top of the line, is the bolt together converters that will have a ring welded on here with a bolt flange that will bolt to either an aluminum or steel, one-piece front cover, and that's what we have here. This one's out here as an example of, basically as good of a converter as you can get, and priced accordingly. So that's the differences, between a really cheap, not good enough converter, and a plenty good enough converter, and a really, really good converter. And you're going to see price differences between all of these. So the tab thing is just, again, this converter, in my opinion, is not good enough. The tabs are not good enough. How much more could a ring like this one possibly cost? I mean, come on. That ring should be a bare minimum on a performance converter. So the tabs are not good enough. The inside is really not good enough. So the next thing that needs to be done for this to be considered a performance converter is this impeller or pump needs to be reinforced. So from the factory, these are really just thin steel blades stuck through and bent over. That's all they are from the factory. I'm sure there are some factory converters that are welded, but all the ones I've seen are just, bent over like that. Now the fins are welded. They use some type of welding process to attach them into this cover, but the actual assembly is not welded. It's just crimped together. So this company took and tried to MIG weld this, and I say try because they missed on some of the fins. So, but in 4 spots, that's not good enough. Like, why not just do all of them or half of them? 4, and then to completely miss the fins, like right there, those tack welds completely missed. That does nothing. So again, not good enough. Then the turbine, they did the same exact thing. So on the turbine, they tried to tack it in a few spots, and I didn't mention this earlier, but this is the other part that needs to be modified, is the turbine hub needs to be changed to the appropriate spline. A good converter will have a hardened turbine hub. This one is not hardened, and I know that because I scratched it with a file, and it's really, really soft. So in a high-powered application, the splines are just going to get beat right out of that. Also, I would prefer if they would have machined a journal onto here and put a bushing in this drive cover. That way it could be used in a application that doesn't have a front bushing in the stator tube, which will increases converter exhaust flow. But I think that bushing this turbine hub should be done on all performance applications, and this one was not bushed. So it doesn't have to be done with a Turbo 350, Turbo 400, but for a performance application, I think it should be. But it was not on this particular converter. So again, not good enough. Now let's look at the way past good enough, as badass as it gets. So the impeller on this badass bolt together converter is fully furnace brazed and then hand tigged on top of that. You can tell that this is going to be way stronger, right? And in this company's defense, I don't know what power level they say this converter is good enough for. I say it's not good enough because the quality is horrible on it, and there's no arguing that. Like, I didn't show, but even on the turbine, they missed the fins in several spots. So the quality's not good enough. The quality control isn't. I also think that the design with only tacking it in 4 spots is, again, not good enough. But if this converter was just intended to go in a car that just drives around leisurely and doesn't make any power, then it probably is good enough. It fits. I haven't measured it. I didn't measure run out and stuff before I cut it apart. But if overhaul height is correct, run out is good, it's balanced pretty well, it's probably okay. But Is it a performance converter? Will it work with 500 horsepower? No, no, and no, it will not. This thing will destroy itself with any type of decent power and traction on it, guaranteed. So, and they do. Like, the only reason that I have one of these converters here that's cut open, that's not destroyed, is because this guy had just bought this converter and he had put it in the car and ran it, and whoever built his tranny did such a horrible job that the tranny smoked itself before the guy even ever had a chance to give it any power or anything. I don't remember exactly what happened to it, but I was trying to convince him that this converter was not good enough, and I said, you know what, let's cut this thing open so I can show you how bad it is. Once I cut it open and showed him a comparison converter, he was like, wow, thank you, because he had bought this from one of the big retail performance parts places, and the salespeople told him that this converter would work. You're going to laugh at this. He had this behind a 468 with a 671 on it. It was in a street rod with like Mickey Thompson Sportsman tires or whatever, but big Sportsman tires. And I mean, if I would have built him a nice transmission, or I did build him a nice transmission, but if I had built that nice transmission and said, yeah, go ahead and run that converter, it would have been back, guaranteed. So we built him a nice converter for it. We still use the GM245 core, which is what this one is built out of, but we built a nice strong converter for him, and he's out there running and loves it. But I was glad that he was able to donate this so I can show people what kind of converters not to buy. So that is basically what I wanted to get out in this video, is that almost all of your performance and race converters are going to be built out of some used OEM core, with a few exceptions. I know Neil Chance has the stamping presses to stamp out new impellers and turbines. I don't know which ones. He might have info on his website. I talked to him at PRI 2 years ago, and he told me that he had bought the equipment to do that. Whether he's doing that now or not, I don't know. He probably is, knowing Marty. The guy's a madman, but he had bought the equipment so that he could stamp out new ones. There are probably a few. I want to say TSI had kits that had a new furnace brazed impeller and turbine in, I think, the 245 configuration, but don't quote me on that. But those are kind of the exceptions. The majority, like 99.99% of your performance converters, are going to be built out of some used OEM core. 8-inch Opal, those were super popular back in the day, still are for a lot of applications. You're starting to see the bigger cores getting used because guys are making way, way more power than we used to back in the day. Remember when a 13-second car was, dominate the streets? Now it seems like everybody has a 10-second car, right? At least. So starting to use more of the GM245 stuff. And the 245 is a super versatile converter. It can work from a stock power level clear up to, usually if you get up in the 1,500 horsepower range, maybe a little below that, you kind of start to outrun the 245. But with a lot of this no prep stuff, we got guys making a couple thousand horsepower that are in this size converter, and it's working well. Whether they're putting down a couple thousand horsepower, I don't know, but they're using the 245 core at that power level. If you got traction and you're going after like a radial record or trying to get up in the top of the qualifying sheet on a radial deal, you're going to probably be in a 252 Nissan or a 258 GM or even the 264, which I think is also a Nissan. That's what the converter guru is going to figure out for you, is which core they're going to put you in. I talked about that in the last video, so I don't want to keep repeating myself with everything, but the converter guru is going to figure out which core to put you in and then how to configure that core to work with your application. And we talked about that a little bit in the last video. If you get a chance, check that video out. I just posted it, I think, yesterday. And I talked about some of the numbering that some of the different manufacturers use and how to decipher some of those numbers, because it's like voodoo to people, like, oh, what's that number mean? And still voodoo to me too a lot of times. Luckily, I have friends that can help me out with that stuff when I can't figure it out. And you can always call the manufacturer if you can figure out who made the thing, because that's another challenge too, is a lot of people don't stamp them. I stamp all the ones that I put out there, BGRT, Bub Again Racing Transmissions, and I have some numbering that I use to kind of help myself, but I do it by invoice number, and I put my initials on there. So I can tell if it's a converter that I did for somebody or if it's or if it's not. So, but anyway, I've seen some really nice converters that have no stampings anywhere on them, and I don't know if that was an oversight or if some of the manufacturers are doing that on purpose. But I will say the converter gurus, the guys that do this stuff all the time, they can usually look right at their stuff and tell. And they're like, when we're talking about using a GM245 and using a lot of the existing OEM parts or readily available OEM parts, like the stators and all of that, it might be hard to figure out who made it. And there are kits available to retrofit this that a lot of the converter companies use, you know. But if you're talking about like one of the really custom, you know, like this converter here, everybody's going to look at this thing and know right away who made this. And the guy that made it is going to look at it right away and know exactly what it is. And if you open this thing up and show this to a converter guru, they're going to immediately know what that is. They're going to know what that stator is and how it's going to work. And then on top of that, this particular manufacturer stamps everything in there. I mean, he's got his phone number. He's got, looks like an invoice number. It's a 258 millimeter. I don't know what that means. I don't know what that means. I don't know what that means. It's a 1/4 inch mid plate. It's set up for 1 3/16 input shaft and has the dual bolt pattern on the front cover. And he put a date on there. So he put a lot of information on there. And his name. And his phone number. I didn't mention that. So, you know, he's got all kinds of info on that converter. So good. That's good that he's got all that. But anyway, that's it for the video. That's what I wanted to go over. If anybody's got any questions, post it up in the comments, please, and I'll try to answer questions as if I know them, or if I don't know them, I'll get the answers. So, have a good night, everybody. Have a good weekend.